The height of a helicopter in feet is given by the following equation. S of t equals 600t minus 2t cubed after t minutes. We're going to be asking a different question today, but we're going to be following the same steps. So let's read this question together. At what point in time does the helicopter begin its descent? Well, I kind of drew a picture of what happens with the helicopter. It goes up, rises up, and at some point it starts to fall again, or it starts to fall. So what is this time right here where it goes from going up to going down? That's what we're going to figure out. Again, step one is always to write out what they give you algebraically. We're given the position function. I do want to say that for motion problems, you could be given velocity, you could be given acceleration. You might have to go in reverse, and we will see some examples like that. We're starting off simple by just being given the position function. Next, we're going to convert what is given verbally to algebraic expressions. So, the thing is, we've got to figure out how to convert begin its descent into words and into an algebraic expression. And a lot of students have trouble with this, but when you draw a picture like this, this can really help. So notice what happens right here. Its position goes up, 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 and up, and then all of a sudden its position starts to fall. Well, when the position, if the change in position is negative, we are talking about what? We're talking about a negative velocity, correct? When it's positive, it's a positive velocity. So what happens at this point right here? If this were the helicopter, in order to go from going up to going down, what has to happen to its velocity? Well, if it's going from positive to negative, it has to be what? And if you said velocity must be equal to 0, you are correct. Okay, it's not just vertical motion, it's also horizontal. If you're in your car and you're going forward and you have to back up, guess what? At some point in time, your velocity has to be 0. You can't go from forward to back without it being 0. Pretty interesting concept. I remember when I first learned that, I was like, wow, that's crazy. But nevertheless, it's true. So we want to figure out when v of t equals 0. And when it's 0, we want to figure out what t is equal to. Okay? So that kind of leads us to step 3. They pretty much go hand in hand. Again, it's convert the verbally stated question into an algebraic expression. So t is equal to, whoops, what is t equal to when v of t equals 0? Okay, so here's the question. At the end of the day, we want to have some kind of time, right? We want to have some number for t. So let's do that. Again, we want to remember that the derivative of position, s of t, is v of t. And as a future reference, the derivative of velocity is acceleration. So I like to draw that map out every time. You know, I do these steps for a reason, because when you first learn position problems, they can be difficult. So learning these steps will help you manage all of that, which seems chaotic at first, and help it make sense for you. Now we're going to solve the problem using either initial value derivative procedures. Okay, I'm not going to reinvent the wheel. We already figured out that this is the velocity function, 600 minus 6t squared, and we did that by finding the derivative of the initial. So I'm just going to rewrite that down here. 600 minus 6t squared. Okay, so v of t equals 600 minus 6t squared. And we want to figure out when the velocity is 0, right? Because again, we said that's when the helicopter goes from going up to going down. Its velocity right there is 0. So we're going to set this equal to 0. Okay, and then we're going to add 6t squared to both sides. So it's going to become 6t squared equals 600. Next step, you guessed it, let's change colors here, is to divide by 6. We get t squared equals 100. And then when you take the square root, you get plus or minus 10. We don't have negative times, so t equals 10. So we figured out that the velocity is going to be 0 whenever t is equal to 10, which tells us that's when it begins its descent, right? It must be beginning its descent at t equals 10. Pretty cool. So let's go ahead and answer this verbally, and we'll be done with this question. Okay, so the verbal answer is the helicopter begins its descent at t equals 10 minutes since its velocity goes from positive to negative there. Now, you do want to show a chart for this as your reasoning, so I do want to say that just because it's equal to 0 at t equals 10 doesn't mean that it begins its descent there. It has to be going from positive to negative in order for that to be true. If it went from negative to positive, that means the helicopter would have been going down and then back up. So it would have began to ascend. So we did actually make a chart when we did the question on speed, and let's see if I can find that chart right here. We can see that it's positive on the interval 0 to 10, and we prove that by plugging in a test number, and it's negative from 10 to 12 or 10 to whatever. So we know that it is positive on this interval, negative on this interval, and a lot of times you need that chart to actually prove that. So I'm just being a little technical there, okay? Just to say that be careful when you're writing an answer and giving a reason why something is true, and in this case it's because the velocity goes from positive to negative at t equals 10, meaning the velocity is equal to 0. If you have any other questions about this, one more thing, let's take a look at the graph. So again, this kind of gives you a better idea. Let's erase what we had before because this was answering a different question. The position graph gives you a pretty good idea of exactly what's going on with this helicopter. Here's its position. It's going, now again, it's a vertical change, but the position graph is just, of course, going to be moving to the right since time is moving. But anyway, you can see right here at time t equals 10, helicopter's reached its maximum height, and unfortunately, I don't know if I can zoom in to show you that. Let's see here. Oh yeah, there we go. It's reached its maximum height of 4,000 feet. And after t equals 10, it starts to go down again. And we can confirm this with the velocity graph. At t equals 10, its velocity is negative, and it goes from positive to negative, meaning after t equals 10, the velocity is negative, meaning the helicopter starts to fall down. So that's it for this question on the helicopter beginning its descent. If you have any other questions about this, let me know.